Hi and welcome. This time around I have a quick project, or hopefully a quick project, where I'm going to modify the belt sander I designed and built a few years ago. If you're interested, I have a link in below this video, and there's a playlist available on my main page for how I built and designed this belt sander. It took me over a year to design, through like 20 iterations, and quite a bit of time to build. It's worked really well, but I did make one mistake that I wanted to correct. What I discovered was to keep the belt centered, if you crown the pulley on both sides, so the driven pulley's on the bottom and the idler pulley's on the top, if you crown them, it tends to keep the belt center. So I crowned both pulleys by about an 1/8 inch per foot, I think it was, or 3/16 per foot, I forget. I looked it up at what the standard industrial crowning of a pulley was, and I followed that. However, it turns out that the idler pulley should not be crowned, or doesn't need to be crowned. And what ended up happening was the belt puckers in the middle, and it wore a little, cutout in the center of my fence here, or my table, which I don't like. So what I want to do is I want to disassemble this whole thing, pull the top part out, and get to that pulley and remove the crown. So we're going to take it and we're going to machine it back down. In order to do that, got to disassemble the universe. It's really unfortunate. To give you a better sense, here is the pulley right here, and this is just the idler pulley. It's not driven, so there's just bearings in the pulley itself. On this side is a pin where it rotates, and on this side has an eye that just raises the shaft up and down. The pin keeps it from going this direction in and out and allows it to rotate. And then down here, this brass bushing is threaded into this, or not bushing, but this threaded nut that I made it out of brass. And it uses a little pin that I stick in there just to rotate this, to adjust it. These two set screws tighten this down so that it doesn't move after it's adjusted, and the whole thing works pretty well. However, I want to take the crowning off of this pulley, so I've got to disassemble it. And in order to get to it, it's going to be quite the challenge. I don't think I can leave the back on, but we're going to try. I'm going to see if I can get to it from the front. So the first thing I'm going to do is I'm going to loosen this pulley here so I can get the belt off. But I also need to remove the custom sanding dust collection attachment I made, and that's just removing this guy here and this guy here. And it should come right off. That was a whole separate project in and of itself. The dust collection bit is just a 3D printed thing, and it's so close that I think I gotta loosen the belt first. I can't remember, it's kind of tight in here. So let me get that out. So here is the 3D printed dust collection. This is the front right here. The belt goes this direction. So the sparks are coming down, and you can tell the sparks melted into the 3D print. The air is sucking here and here. And unfortunately, the sparks hit the front and melted it. What it really needs is like a piece of metal across it to protect it, because obviously the 3D printed material can't take it. This is a very close fit, and unfortunately all this material sticking up is preventing it from coming out easily, so we're gonna have to fix that too. My first approach to cleaning this up is just to take a scraper and run down this and see if I can get the melted parts off. It seems to be working, getting big chunks, but boy, it did some damage. This baked on spark crud actually melted and fused back into metal again, and it's been exploding razor blades. That's the second razor blade I've gone through, exploding the tips. I need to use something heftier. Ultimately, this is the kind of scraper I used. Got most of it off. It's amazing the damage it did. And it's amazing that the little sparks coming off the belt actually fused into solid metal, where it was really hard to break through that crust. That's really weird. So here's the pulley with the belt off, and you can tell that it was pressing mostly in the middle here. Bearings are still great. So I don't think I can get this off with this guy installed. I think I have to remove it to get that off. So down in here, you probably can't see it, but there's a worm gear and a worm, and that's what controls the height adjust on some Acme threaded rod. And the beauty of that is you can't run it in reverse, so I've never had problems with the tension of this guy loosening. I thought maybe vibration would be a problem, but it's actually never been an issue. This thing has worked really well. So I took the top off. So now I should be able to take this whole assembly and pop it straight up and out, and then I can work on the bench. So I was wondering how I could ever do bellows or something to keep this area sealed, because you can see all the debris that got in there. To be honest, I've never been able to figure out a good solution for the bellows. It would be nice. Fortunately, the threaded part is up in here, so it stays clean. It's just the rotating part on the bottom, and there are some seals there to keep debris out. And there's 2 pins back there that this whole thing rides on, with some bronze bushings inside there, if you hadn't watched the videos. So what we're doing is we're just adjusting the tension essentially until this guy pops all the way up and out. And then I can work on it. It's a million revolutions, however, because I had this thing going way in there for stability. I want it to be very sturdy, and it actually works. You can also tell some of the metal bits get under the sanding belt, which this is crowned in the middle too now, unfortunately. This material I spot welded on here, this is spring steel that's hardened, and it's actually quite hard, but it's still warped. So what I might do is might replace this as well, break these spot welds, and spot weld on a thicker piece of material and see if that works out. Here's the whole idler removed. So there's the bronze bushings and the bronze nut, the Acme threaded nut. And we're going to clean all that very nicely before we put this back together. And then I need to just get this pulley off of here, and we need to remove the crowning from it, and hopefully that'll help. Another thing I discovered here is some of those sparks, those metal particles, are hot enough that even after they travel all the way around the belt, they're hot enough to melt into the aluminum. And I'm having to pick some of those out here. There are a bunch of them all over there that melted in, which is pretty amazing. Also, to clean it out, you'll notice I made these holes all the way through. They're through holes, and I have caps on the back so that I could always get to them if I needed to push those out. All right, so there's a taper pin here. Here's the pin on this side, and here is an Allen screw that keeps it in place. So if I pop this guy out, I should be able to push the pin out, and this thing should be able to lift up and come right out. As I recall, it was a bit of a challenge getting this pin lined up in the first place. So again, that pin lets this thing tilt up and down because it needs to set the angle to get the belt centered on it. Actually, well, tapered on the end, heavily tapered so that it just seats in here. I forgot how I did that. I could go back to the drawings to look, but anyways, lining this up was a bit challenging. And so I think now if I take these 2 bolts off here, this side will come off. I can just pull this straight out. So I won't have to worry about it because this side is just floating. All this side does is rotate. Okay. So this guy is a really snug fit, which is good, as is this slot here, and I can just pull this guy off. And the spindle comes out, or the center shaft of the spindle comes out. Just remove these 4 bolts. This side comes off. Same with this side over here. So I was wondering how good a job the sealed bearings have done at keeping the inside clean, and they have done a really good job. I don't see any debris inside at all. So I just need to remove the other side, and we should be good to go. There we go. Here's the pulley by itself. The pulley was made out of 1/2-inch material originally, and has worked out pretty well, actually. So now, how do we hold this to turn it? Taking a cue from Curtis at Cutting Tool Engineering, I can grab the inside of this, which I don't want to damage. What I might do is put a piece of tape there just to protect it a little bit, both sides. It's not like it's a critical surface, but those pieces slide in very tightly. So if I get burrs there, it's going to make it a pain. I'll have to take some sandpaper and remove them. I can catch the outside of these guys. Let me just do it real quick. So there, I've just got it loosely grabbed and flat against this. And then I've got a 4-jaw chuck over here, which I can also grab on the outside, pop this guy in here, tighten each of these 4, get this guy centered, and then cut it. That's probably the approach I'm going to take for this particular project. There is another way to do it, turning between centers, and I'll show you that in a sec. Another solution is to go between centers and use this expanding mandrel on the inside of this guy, which also is another very reasonable solution. Take a while to set up, and this expanding mandrel is going to have to expand quite a bit to meet this. It's spec to meet this diameter, but boy, you're going to have to tap it way down here, which I guess is about center. So that makes sense, but boy, that'll be a bit of a challenge. So I think we're going to use the chuck solution only because it's easier, but the expanding mandrel is probably a better option if you do not want to mar any of your quality surfaces. Okay, so I've got this guy in here, the stainless steel shim stock's in here, this spaced out from the chuck jaws so I can cut right up to it. But in order to get this square, I'm going to have to indicate it in, I think. But just to double check, I'm going to use some spacers I've got that'll fit in here to just keep this spaced off the chuck evenly. So I bought some strips of tool steel, Starrett tool steel that are ground. So they're pre-ground, which makes it very convenient because they're within like a thousandths thickness of each other, which is plenty accuracy for this particular part. Oh, and I went and did all of that, and I forgot to check where the gap is. So the gap is right here. Okay, that was challenging to get in there. So I just snugged it lightly. Let's see how square we actually are. It looks like 20 thousandths or so. Or 30 thousandths. There we go, there's like half a thousandths. So now I can snug that up. If I snug it too much, I'll deform the aluminum, so I got to be careful I don't over tighten it. That's one of the advantages of a 6-jaw chuck. And now I got to put the 4-jaw in and do the same thing. So getting a 4-jaw chuck on a rotating, a live 4-jaw chuck on your tailstock is a really handy tool to have. I learned this trick from Curtis down in Australia over at Cutting Tool Engineering, so check out his channel. He uses this technique all the time. So, well, that last bit of tightening kind of knocked it out. So I know it's over here that I got to deal with this. So I'm going to dial that in and I'll bring you right back. So if you're curious, it touched in the middle here. You can see it scored the middle and you can see the gap here on the end. And if we're wondering how far in that is, it's about 50 thousandths. So that's what we'll be taking off, and we'll do it in a couple passes so we can be light on this. Oh, actually that's taking the whole thing. Using an aluminum positive rake insert, aluminum cutting positive rake insert. I might want to pull this out a little bit, only because that'll be a lot to take in one pass. So that was the first pass. Took off 25 thousandths, so we took off half of it. One thing you will notice is a little bit of deformation here on this guy, which I guess is not too surprising. All right, so we're going to go and do the finishing pass here. And this will clean up all the way across. Except for the little bit of outer round portion there. There is a little bit of deformation because of the 4-jaw chuck, I think. For extreme longevity, it could have made these pulleys out of cast iron, or even better, put a cast iron sleeve or a steel sleeve around the aluminum. That would have been a good idea too. And that would have helped make this last a lot longer. Because there is some wear on it, although I've used it for more than a year now and it's not bad. I don't use it every day. I think if I used it every day, there might be different considerations I'd have to account for. I definitely think putting a press fit sleeve on this would be a good option. So it would keep the pulley not overly heavy, but add a little wear resistance to where the belt rubs and some of those chips go underneath. And we're done. That was pretty straightforward. So you can see here also, it didn't clean up a little bit of it, and I guess that's because it's not perfectly symmetrical. It's by thousandths. I can't even feel that transition. I dialed it in to within about 1/1000th and a half. I figured that was close enough. Anyways, I think we're good to go. Now for the reassembly. So to identify the sides, I look for the marks I put on here. 2 on this side, which means it goes with that piece there. So this piece here, this single one, goes with this one here. Okay, great fit going back. Now I need to get this side lined up. The 2 scratches survived there. And here's the shaft with the 2 scratches there, so it goes in like so, and this lines up like so. There we go. Very nice fit. Alrighty, now I got to get this guy back in here. So there are a couple little burrs in here I need to remove. Just make sure the shaft, because the shaft was a perfect fit in here, and I actually had to tap it out with a hammer. It was such a good fit, which is actually what I wanted, to be honest, because that means that it stayed put and there wasn't any wiggling to cause wear. So that's actually a plus for me. I'm realizing now that I probably could have tapped this out and left the pin in place, which would have been handy. Oh, well, figure it out next time, right? Okay, there we go. So let's see if we can get that pin aligned. I'm going to see if I can put it together the way I want to take it apart. There we go. I actually got the pin in there. So then this guy would go in here like this, and this guy would fit just like so. Yeah, I could have taken it apart that way. Save myself some misery. Okay, wow. Live and learn, huh? That actually went in really easy. This was all much easier than I thought it was going to be. I thought this was going to actually be quite a bit more difficult. So I'm interested to see if this is level anymore, because this set screw and this set, there's some set screws that tighten on this that have a plastic piece on the end that push against this just to cause friction. So I can still adjust the height on this guy by raising it up and down. There's the bottom of the 1/2 inch 20 shaft that feeds through this guy. So we've got very fine control here, and we'll see when we start this guy up how it works out. So you can see how this got cupped too. So it got heated in the middle and it warped. This is hardened steel and surprising amount of wear on this guy. So I have another piece of spring steel, but it's in a annealed state, so it's not hard. I don't know if that'll work, and I don't know if I can spot weld it because it's kind of thick. That's a couple questions I don't know the answer to. And if you're wondering about the spot welds, not one of them gave up, which is pretty impressive. This thing is really on here, so that was a better job than I expected, because now getting this off is going to be a challenge. Either that or I have to remake a new piece. Well, with a little bit of effort, I was just able to peel this off, and you notice it just broke around the welds, probably where it didn't get annealed very well and the material became hard and brittle. It actually took quite a bit of force to get it off. I just sort of work hardened it back and forth, and off it came. So this is unannealed. This is annealed, so it's softer, but it's a bit thicker, so I'm hoping it'll work better. It may not. It may warp too. We'll be back in the same boat. All right, so I've got the material on here with a couple cant twist clamps, and I guess we're just going to try and go for it. We're going to get these guys in here, put some pressure, so get it in the middle, put some pressure. Yeah, it looks like they're sticking. This Harbor Freight thing is working out after all. All right, I'm going to take one of the cant twist clamps off. I'm just going to work my way across here. Yeah, it's holding nicely. So this time, instead of just having groups of them, I'm going to go all the way across. Hopefully that'll prevent it from warping, at least at the top. It is going to make it kind of challenging to undo it next time, though. Makes me wonder if I should have gotten hardened material. That probably would have been better. There's a fair amount of abrasive and grit that gets under this somehow. So now I see why they have the foot actuated ones, because there's a lever over here that I got to put a fair amount of pressure on. Now I could adjust it so it would lock in place each time, but I think that's more effort than it's worth. But they have foot pressure ones where the foot puts all the pressure on this guy. Ow! That's really hot. Shouldn't have touched that. Got some melt marks on my hand. Keep forgetting how hot this is. I just set this on here and melted it in. I had to sand off the copper contacts on this because they were getting kind of gunked up. And I could tell I needed to do that because it was hard to make contact and get the current to flow. And that's it. It's on there. So I'm going to take and file this side down here. Oh, and it looks like that wasn't cut perfectly straight. Yeah, so I got to grind this so that the belt doesn't catch on this sharp edge. So I'm going to round this edge over and let this all cool off. Whew, too hot to touch. Yeah, this is going to have to sit a while. Well, Harbor Freight spot welder worked pretty darn well. This is thick material, by the way. If you're looking at it, it's probably like 60 thousandths. Just guessing. Let's see. Let's measure. 50 thousandths. It's pretty thick material. Thicker than probably it was designed to work with, but did a great job. All right, so we're ready to reassemble this guy now. So I can just put this guy back on here. And originally I was too lazy to take this guy off again because it's kind of hard to get on. And so it was a pain without it with this piece in place because it actually overlaps. That was an oversight in my design. But now it's pretty easy to put back actually, although this screw is a little close to this edge. So with a T-handle, you have to go in at an angle. These are the Harbor Freight dirt cheap T-handled Allen wrenches. And I gotta say, they're crappy. They break real easy. The balls break off almost immediately, any torque at all. So just so you know, if you're thinking about it, maybe think twice, get the better set. They have the Icon ones now, and they're probably a lot better. All right, let's see, because you can maybe see this now. See how that's curved in? I actually surface ground this thing flat, and now it's got a divot in the center, which is annoying to me, but let's put the top part back on. Okay, I cleaned all this with a rag, cleaned these with a rag. Now I just set this down. These are hardened pins and lined up pretty darn accurately. And then you start the threading process, which it takes like 4,000 revolutions of this guy because I purposely gave the mechanical advantage to the worm on this one so that I could get a really good fine adjust. And this thing never vibrates loose. I left room here so that I could do some sort of braking system if I needed to stop this once you've tightened the handle. Never needed it. This does not shift tightness on the belt at all. The first time I put this on, it was actually really hard. This time, it just went straight on perfectly. No fuss, no muss. So that was a nice surprise. So I'm going to get this guy back on. We're going to put the top on. We're going to put the front faceplate on. We're going to put a belt back in. You know, maybe I'll stave the faceplate so you can see what's going on, and then we'll get the belt centered again now that this is no longer crowned. I hope that doesn't end up being a problem. Haven't done any adjustments yet, so I'm just going to turn this on and see what happens. No longer centered. I'm going to recenter that and then I make some adjustments. So here's the adjuster over here. You just use this rod, and I was running it by hand to see where it goes. I don't know if that's a valid test. It looks like it's still going in, so let's go this way a little bit. So since I took down material off the center, although I left the edges mostly the same, these side pieces were just a little bit proud by about 5 thousandths, so I had to manually sand those off. So we got it adjusted center. I can tighten that bit down now. If you want to see how delicate it is, here's this. So here's more to one side. Here's more to one side. So you don't want it to move. And I think we're good. It shifts a little this way when it powers down. Like that. When it starts up, it recenters again. Yep, there we go. I think we're good. All right, so now I just need to put the top back on and the front, and I think we should be good to go. And the belt is now lying flat against this material because it's no longer warped. I don't know how long it'll stay that way, hopefully longer than the previous one. One design mistake I might have made is that the belt is touching, even when it's off, is touching the spring steel backing plate. And it might have been better to have that back just like maybe a 1/16 of an inch, so that only when you push did it push up against the plate. That might have been a better design. That probably was a flaw on my part. Since we're threading into aluminum, I always hand start all the screws. I originally just had a sticker on the front, but I think the brass plate with the paint looks much better. Just got to add the dust collection. Should be good to go. Well, that's about it. If you're wondering about the dust collection, I epoxied a strip of that spring steel that was the backing plate here and epoxied it to the front of the dust collection piece. So hopefully that'll prevent the sparks from melting the plastic. We'll have to see about that. But that's about it. I'm pretty excited. I think this is going to be a big improvement. The belt definitely lies flatter than it did before. When I designed this, the belt was a little bit proud of this by like 20 or 30 thousandths, I forget. But now that I'm using thicker material, it's right on it. That may not be good. Time will tell. Maybe I'll have to adjust it again. Thanks for watching. Hope to see you next time.